Hi friends, welcome to my channel Educational Tips by Harikata. This is Harikata. Today our topic is purification of a compound by prep HPLC. For example, one compound received for a purification. For that, how to develop a method based on the analytical HPLC today we have to discuss. For example, one compound received for purification. Its analytical data looks like this chromatogram. This compound having the major four peaks. The in between these two peaks we required based on the client requirement or the R&D requirement. These 2 and 3 which are very closed and in between the two major peaks. These are the required peaks we have to isolate, and we have to develop the method for separation of these two compounds. This is the analytical HPLC chromatogram which the R&D people or somebody given to us for the isolation of a compounds. Okay, this is the analytical HPLC. This is the method which is used for the analytical chromatography HPLC. Here for this analytical HPLC used mobile phase is mobile phase A 0.1% TFA in water and B is acetonitrile, and that flow rate is 1.0 ml per minute, and gradient which is used for the analytical HPLC is time by percentage of B 0 by 10, 10 by 90, 20 by 90 and 20.01 by 10 and 25 by 10. This is the method, and column which is used for the analytical HPLC is 250, 4.6 and 5 micron, and wavelength which is used for this chromatogram, this sample is 235 nanometer for this particular sample. So if we see the chromatogram, these two are very close to each other and in between the two major peaks. So for this chromatogram, for these four peaks we have to develop a method for the better separation. So for that, based on this basic data, we have to change some gradient or flow rate, or in these two steps it is not separated, we have to go for another buffer. So first we have to take same buffer, same column and changes in the some gradient. So now I change the gradient time by percent B 0 by 10, and I put some isocratic for up to 5 minutes 5 by 10, and now gradient linearly increased to 20 by 90 and 25 by 90 and reverse mounting 25 by 10 and 30 by 10. In this gradient system, I injected the sample and I got the chromatogram of this much separation. Means here 3 minutes and 4 minutes in analytical HPLC. Now I got our required impurities at 8 and 10 and some resolution found in between the analytical HPLC initial chromatogram and in the first development. So this is not sufficient for the isolation of these compounds by prep. So for that I will go for the second development. In the second development, what I choose is flow rate is decreased to 0.8 ml instead of 1 ml, and gradient also changed to the 0 by 10, 5 by 10 is common, and then here 20 by 90 I used. Next I used 20 by 50% of acetonitrile and 25 by 70% of acetonitrile 25 minutes, and 30 minutes 90% of acetonitrile and 30 to 35 reverse monitoring I kept. In this chromatographic system, in this gradient system with 0.8 ml flow rate, same nanometer, I injected the same sample. So now I got the good resolution and better separation in this chromatogram. So if we see, first peak is 7 minutes and second peak required first peak is 12 minutes and third peak is 18 minutes and the fourth peak is at 24 minutes. So I achieved the better resolution, better separation in the development 2. So this is the way to develop a method for the isolation of a compound before going to the prep. In the first method, this is the analytical chromatograph. I will briefly explain once again. This is the analytical chromatograph. The all peaks are very close to each other. From this, based on the basic data, I am changing the gradient condition without changing the flow rate. Only the gradient change, I got some separation between the 4 peaks. This is not sufficient for the isolation of compound by prep purification. So that's why I changed flow rate 0.8 ml and gradient I changed slow gradient 20 by 50, 25 by 70 and 30 by 90 and injected the sample again. In this I got the better separation. I achieved the better separation. This method will be optimized to go for the prep purification. Okay, this is about the development of a compound before going to the prep in analytical HPLC. Okay, in the next session, how to transfer this method into a prep method, means prep column. How to change these flow rates and injection volumes, convert into the prep system which is used for the high dimension columns. For analytical column to prep column, how we have to change flow rate and gradient, all will be discussed in the next session. Thank you. Thanks for watching my videos. Thank you very much.